All right, you guys will be able to identify and use properties of similar triangles. Woo! Similar triangles. I do have a trooper tie on.
Do you think they make stormtrooper button-up or whatever you want to call those shirts?
Like a dress shirt?
Yeah.
Probably.
Hold on.
What am I supposed to hold on to?
I'm not wrong.
Oh, interesting. You give me the instruction, but you don't give me the tools to do the instruction. That's good leadership.
That's like,
All right. So, similar triangles. Okay, well, first let's talk about congruent. Okay, we talked about things being congruent before, right? That was like a whole lot of last chapter. So we had congruent. The symbol for that was the two equal signs and the little squiggly on top, right? Some people kind of think it looks like a toothbrush with toothpaste on it. They have the same angle measures
they have a full suit.
and side lengths.
Oh no. Kenny, you should just get that from Mr. Carlson.
All right, attention up here, please. Thank you. So, we notice the triangle. These two triangles are congruent because they have the corresponding angles being congruent, and their corresponding sides are also congruent. That should be a little more familiar to us after the last chapter, I would hope. Now we're going to introduce this idea of similar polygons. So go and flip to the page to the top of the next page. And for similar, the symbol is just going to be just that squiggle that was on the top, just kind of the tilde that would be in Spanish. So similar polygons still have the same angle measures. That part's still true. But instead of having the same side lengths, they can be different side lengths. So corresponding angles are congruent. That's still the case. But the ratio of corresponding sides are equal. Notice how we just did ratios last class, right? And now we're going to be using ratios. Man, how well thought out is that? Okay, that's kind of cool. Okay, anyway, so I wonder who planned that, but it's probably pretty good. All right, so we have these two triangles, A, B, C, and D, E, F, okay? We notice that the corresponding angles are congruent. A and D are both 90 degrees. B and E are marked congruent with 2 arcs. And then C and F are marked congruent with 1 arc. But the side lengths are not the same, are they? The side lengths are not the same, are they?
No.
Okay, so they are not congruent. We know that for a fact. But if we were to take the ratio of these triangles, and let's say we said, okay, let's compare the corresponding sides. So let's compare 3 and 6. So we say 3 over 6. And we compare that to 4 and 8 because those are corresponding as well. So we say 3 over 6. Does that equal 4 over 8? And let's compare it to that third side as well. Does that compare to 5 over 10? What do we notice about 3 over 6, 4 over 8, and 5 over 10? What can they all reduce to? 1 over 2. So, are the ratios the same? Yeah, the ratio of 3 over 6 is 1 over 2. The ratio of 4 over 8 is really 1 over 2. The ratio of 5 over 10 is really 1 over 2. So all these ratios are the same, meaning the ratio of the corresponding sides are equal, which is going to be a common theme for our similar polygons. Now notice, I put the small triangle on top each time, right? And then I put the big triangle on the bottom. Okay, what would happen, you think, if I did the small triangle on top for the first few? So I did like 3 over 6, and I compared it to 4 over 8. But then I said, okay, for the last one, we're going to do the big triangle on top. Does that still work anymore? No, so notice, I had to do the same triangle on top. Now, could I go the other way, though? And instead of doing the small triangle on top, could I put the big triangle on top and do 6 over 3? What would I have to do, though? I have to do the others in the same order, right? I have to do the big triangle on top for all of them. And then what do we get all those equal? 2 over 1 or just 2, right? So the ratios are still equal. Candy, did that answer your question? Awesome. I had a feeling it might. Thanks for staying patient. At least outwardly. I don't know what's going on the inside. But
I was thinking about wearing mine alpaca, to be honest.
that sounds about like you. It does kind of look like a 0. It's poorly written. All right. So that means this triangle on the right is how much bigger than the triangle on the left? This triangle on the right is how much bigger? 2 times. Because these all reduce to 2. So that means this triangle is what compared to the other triangle? The left triangle is what? It's half. because it's 1/2 of when you get the ratio, okay? Notice how that works? Okay. You guys remember doing scale factors back in chapter 3 when we had all that graphing and then we had all the transformations and the rotations and all of that. I kicked over the stool. It was a great time, okay? And then we also had the times where we made the figures bigger and smaller by a set scale factor, right? We said, hey, K is equal to this, and that was our scale factor, okay? Same idea here. We're taking this small triangle, and we're saying, hey, our scale factor is 2, up here in the purple. Boom, it got bigger. All the sides got bigger by 2. The angles, though, stayed the same. Going the other direction, hey, our scale factor is 1/2. Everything shrinks by 1/2, okay? But the angles still stay congruent. Does that make sense? Okay. Yes? Okay, holding on.
Shouldn't we be holding on?
Holding on to what?
Holding on to on?
Holding on to on. I don't have an on, though.
It's on the back. It's on the bottom.
You should get it on then so you can hold on
I
to
should
it.
get it on so I can hold it. That's true. I could just write something that says on it,
That would work.
and then just hold it, so I'm holding on. Ooh, see,
You tell people that instead of like wear your seatbelt and people are leaving the house, you just like, drink water. You should.
No, I don't.
You should. Drink oil, like drive safe and stuff. Like, drink water.
Drink water. Sive Drafley.
Wow.
Don't
Oh,
drink and
drink
drive.
water.
Drink
Yep.
water.
Yep. Rink daughter. Drink water. There.
Drink the oil.
Continuing on.
No.
All right. So, for the figure above, the one we just saw, these two, okay, we can write what's called a similarity statement and a statement of proportionality. You guys remember doing congruent statements? Triangle this, 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 congruent to triangle this, this, this. Do the order of those triangles matter?
Yeah.
Yeah, it super did, right? Whatever you did the first one in, you had to match the second one up. So let's say we call this triangle OABC for the triangle directly above it. What would we have to call the second triangle if we call this one ABC? DEF to match, okay? So we can say triangle ABC is similar, using the similar symbol, to triangle DEF. And that note just says exactly what I said in actual words, okay? Vocally, I should say. So we can also do a statement of proportionality, where we can say, hey, the side length of segment AB over the side length of segment DE is equal to the side length of segment BC over the side length of segment EF is equal to the side length of segment AC over the side length of segment DF. And Mr. Carlson, what does that even mean? That just looks like a lot of letters, and I'm kind of confused, okay? Well, after I give you guys a second to write this down, I'm going to flash back to what the previous image was on here, even though you can see it on your paper right now if you want to, okay? And as we see this, well, I'll put it back in a moment. Notice 3/6, AB to DE. So this is the side length of AB over the side length of DE. And that's what we see there. The next one we see is side length of BC over side length of EF. Well, BC over EF, 5/10. We put that last here earlier, but it's okay. It really doesn't matter the order it's in, as long as I still have the corresponding sides together. I wouldn't put like the 5/8 and the 4/10, because then corresponding sides wouldn't be together, okay? And then the last one, AC over DF, was like the 4/8. Questions on that at all in the purple? All right, Gucci gang, okay? So, here we have another example. We have these two triangles. I want us to list the corresponding sides that go together. Okay, and as of right now, we don't know these triangles are similar or not, okay? But I want us to list the sides that go together. So can somebody tell me, hey, this side and this side correspond. They go together, okay? Chase.
CB and F.
Okay, so side CB and side FE would be a pair of corresponding sides. Very good, okay. Elizabeth?
Side AB.
Okay.
What we do know
Similar to
Okay, side ED corresponds to side AB, would be the way we would word it. All right, and then what would be our last pair of corresponding sides here?
FB and CB.
Okay, Sorry, no, I think we already had that, buddy.
AC and DF.
There you go. Side AC and side DF. All right, now let's figure out, yes.
We do know they're similar though.
Okay, we're going to find out that they're similar. So,
Already know.
what is no, we don't.
But they're set congruent to each other, like the angle.
The angles? Okay. Well, have we learned anything that says that if the angles are congruent, then we automatically know they're similar? Okay, we're supposing that, but we don't know that. So, what is the ratio of corresponding sides? Okay, so now we know, we listed what the corresponding sides were. Now let's say what the ratios are. So can somebody give me a ratio of two corresponding sides? Okay, Seth.
5/15.
Okay, so 5/15. And Seth did the small triangle on top, so we want to keep doing the small triangle on top. Okay, can somebody give me another ratio of corresponding sides? We're going to see if they end up being equal, all these three. Okay, Kenny.
10 over 30.
Okay, awesome. 10/30. Does someone want to give me the last one that also matches small over big? Okay, Elizabeth.
12/36.
12/36. Awesome. Okay, so now we want to simplify each of these three. We might notice they all simplify to what? 1/3. So we call 1/3 our scale factor. Did we just talk about that a moment ago? So because all the corresponding angles are congruent, and the ratio of the corresponding sides are all the same, they're all 1/3, we can now officially say that the triangles are similar. So now we can say the triangles are similar. We know that. Okay, Kenny.
So that.
When it comes back, let me know. So what would the ratio of the perimeters be? Well, wait. First of all, what does a perimeter mean? The what? I don't know if that's accurate.
No, the adding of all the numbers.
Adding of all what numbers? Outside numbers? What does that mean? What are the outside numbers? What do they represent?
If there is anyone else,
I think so. All right. Yeah, no. All right. So Chase was saying here the side lengths. If we add up all the side lengths, perimeter just means the distance around a figure. So how we get there mathematically is by adding all the side lengths. Okay. So what would the perimeter of this small triangle be? 5 plus 10 plus 12. What would that give us if we added 5, 10, and 12? Okay. It would give us 27. So the perimeter of the small triangle
Oh, I remember my question.
would be 27. The perimeter of the big triangle would be what?
81.
Should be 81 if we had 15 plus 30 plus 36, okay? 30 plus 36 is 66. 66 plus 15 will be 81, okay? Now, let's try and do the ratio of the perimeters. We did small triangle over big triangle earlier, so let's follow that same theme. Let's do small over big here now. 27 divided by 81. What number goes into both 27 and 81? Yes, Seth. 9? Okay, 9 goes into 27 3 times. It goes into 81 how many times? 9. Does something still go into 3 and 9 now?
3.
Yeah, 3 goes into it. It goes into it once and thrice. So, right? It's a curved word. All right, so we end up getting the ratio of 1/3. Hey, what do we notice about this ratio of 1/3? It's the same as the scale factor, the ratio of the sides, okay? That's always going to be the case. Fun fact, okay? Kenny.
So I remember my question.
Yes.
You have to put the question marks over the equal sign.
Great question. So, question marks over the equal sign back on number 2. The reason why I do that is because currently we don't know that those are equal. We're saying, are they equal? We're asking ourselves a question, okay? So I do want us to try and put those question marks over there just so that we remember, hey, these are asking a question. These are not stating declarative facts. Until you simplify them and you say, oh, they are in fact the same. Now I can say they're equal declaratively. Okay? Does that make sense? All right, so yes, I do want us to put that. Yeah.
What if like they're two sides at the same length?
I'm not sure what you're asking, buddy. Are you saying the two triangles like this is 30 and this is 30?
No, like two sides are like the same.
So you're saying like 30 and 30? Okay. Then it's an isosceles triangle and you would still go through these things. You'd still want the corresponding sides to be together. Okay? You just have to figure out what the corresponding sides are. All right. Any questions over this that have not been asked? All right, let's continue on. So, we want to ask this question, are congruent figures similar to each other? So we can see these triangles here, and we might note that they are congruent. The corresponding angles are all congruent, and the corresponding sides are all congruent. And even just a much lesser combination of those could prove it, as we went through our shortcuts last chapter. So let's think about it this way. In order for it to be similar triangles, we said the angles that correspond have to be congruent, right? Well, are the corresponding angles congruent here? Yeah? Okay. So angles are congruent. We also say the ratio of the corresponding sides are equal, right? So let's find the ratio of these corresponding sides. So can somebody give me two sides that correspond? Okay, Kenny. 4 and 4. So let's put 4 over 4. Does it really matter which triangle we put on top here? I guess not. Okay. Can somebody give me another ratio of two sides that correspond? Okay, Elizabeth.
5 over 5.
5 over 5. Seth, you want to give me the last one here? 3 over 3. What do you notice about each of those? These all equal 1. So, were the ratios of the corresponding sides the same?
Yes.
So, congruent figures are also similar by our definition of similar. So, are congruent figures also similar to each other? Yeah, they are. Technically speaking, they are. But what's the scale factor here? What is the scale factor on this when they're congruent? 1, because they're the same. You don't have to multiply or divide by anything. Okay? Because if you multiply or divide by 1, you just get the other number, don't you? Okay? Questions on that? All right, Dank, Dope, and Liddy. So, Seth, here's an example we were talking about. Here's some isosceles triangles. Okay? We might note we have some corresponding sides, right? AB corresponds with DE, and AC corresponds with DF, and BC corresponds with EF. Okay? We want to know, hey, are these polygons similar? And if so, let's write a similarity statement and find the scale factor, okay? Well, hey, what are we thinking? Do we think these are similar?
No.
Okay, here's some initial no's. What's our reasoning for that?
3 and 4 are not the same.
Okay, 3 and 4 are not the same? Okay, well, earlier, 10 and 30 weren't the same, but these were similar.
But they don't add up to be the one. They don't have a common denominator.
Okay, so right now we don't know the corresponding angles are congruent, do we? Okay, currently we don't know the corresponding angles are congruent. We know B and C are congruent to each other, and E and F are congruent to each other, but they don't have any corresponding angles being marked congruent, okay? And then if we try and make the ratios here, we could do 3 over 4, compare that to 5 over 6, and compare that to the other 5 over 6. Now, we probably suspect that 5 over 6 and 5 over 6 are going to be the same, right? Okay, so that's probably actually equal. We can probably determine that. But 3 over 4, is that going to be the same thing as 5 over 6, do we think? Okay, you guys can actually type it in a calculator if you want. Someone type in 3 over 4 to a calculator. Someone tell me the decimal of that right now.
75.
0.75. What's the decimal for 5 divided by 6? Nope.
8.83 repeating.
0.83 repeating. Are those the same?
No.
No. The other one's still 0.83 repeating. So, are all the ratios the same either? No. Okay, so these are definitely not similar. And now, that's enough to say because this up here in the blue isn't a sufficient explanation. So this up here in the blue is a sufficient explanation for what we know.
Let's go.
Where are we going?
Home.
Well, never mind. If you decide, you aren't going to go anyway. So, just like Red Lobster. All right. All right.
They were like, "You want to go eat?" And I was like, "No." They're like, "Well, okay."
All right.
And they left.
All right.
Like,
At least it came back. All right. Any questions on this one?
I never said that. I never even replied to they came back.
Yeah. I assume they did. All right.
Well,
Find the missing length in the triangles if the triangles are similar. And in some problems, we just have dots. And we're going to say those are corresponding and congruent angles. All right. So here we have two triangles, don't we? One triangle is inside of the other big triangle. Do we notice that?
Yeah.
Okay. So this triangle has a side length of 24 and 28.
ha ha ha.
This triangle has a side length of what?
30.
30. How do we get 30?
24.
24 plus 6. Okay. The side length isn't 6 because otherwise somehow the big side length is smaller than the smaller side length. That would make sense. And then do we know this big side length over here?
Yeah.
No, it's x. That's what we're trying to find, okay? So we can set up a ratio, okay? So these triangles are similar, meaning we can set up a ratio already, and now we can solve this ratio. Seth, do you have an idea of what we're going to set up?
Did we already do this? Like somehow different?
No. We did ratios last section, but we didn't apply it to triangles yet. So this is the new part. Does anyone have an idea of what we might do here for our ratio? Okay, Billiam, what are you thinking?
28 over 30.
Okay, I'm actually going to disagree with you on that one. So Billiam said 28 over 30. I want to talk about that. 28 is dealing with a small triangle, right? And then 30 is dealing with a big triangle, right? Okay, but are 28 and 30 on corresponding sides? No, they're not, okay? So that's going to be an issue for us. Elizabeth, what are you thinking?
Do you think, could you do x over 28?
Okay, you could do x over 28. That's big triangle over small triangle, but they're corresponding sides. So if you do x over 28, how do we have to do the other side of this?
6 over 24.
Okay, not 6 over 24, but what's the big side length?
Over 30.
30 over 24. So notice,
Whoa, where's your exclamation or your question mark then?
so this, great question. We know these triangles are similar already because it was told to us that they were in the instruction. So we don't need the question mark because they're similar, we know the ratios are equal. Great question, Kenny. So this is a declarative statement, they are equal. What we're trying to answer here is what x is, not whether or not they're equal. Okay? Now, the reason this proportion works, I want to walk through this. When we're doing proportions, we have to check 4 things. We have to check both vertically and both horizontally. So, vertically, x over 28, corresponding sides. Vertically, 30 over 24, corresponding sides. Okay, so there's something going on there. There's a relationship. Horizontally, x and 30, both a big triangle. Horizontally, 28 over 24, haha. Both the small triangle. So no matter what way you look at this, horizontally or vertically, any of those 4, in both horizontals, both verticals being 2 plus 2, 4, there's a relationship going on there. There's a connection. Okay? The one earlier that was suggested, the 28 and 30, do 28 and 30 have a connection? They're not part of the same triangle, and they don't even correspond. So there's no connection. That's why that wouldn't have worked. Okay? Question on that at all? What I'm trying to say is there's other ways we could have set this one up, and it would have been okay. So the way we know this one wasn't okay is because if we walk through vertical and vertical, horizontal and horizontal, we notice there's some sort of connection between them any way you go about it. Now, how do we solve this ratio? How do we do? Yes. Okay, what we did last section, right? Where we cross multiply, right? So you do x times 24, haha. What's x times 24, haha? 24, haha, x. Then we do 28 times 30. Do we know off the top of our head? What?
840.
840? Dope. Maybe next time I won't make you say it 3 times. My bad. Then we divide both sides by 24, aha. And x is 35. All right, cool beans. So now we know this side length is 35. You can check your work by plugging in 35 back in and making sure the equation does work if you wanted. Does equal both sides, okay? Does anyone have an idea of how else we could have set up a proportion on that one? Actually, let me back up. Let me pretend I didn't ask that question, and let me ask that question on letter B. On letter B, we have these 2 triangles, and we're saying these dots are congruent angles, and the right angles are also congruent angles. We're trying to find D, but we already know they're similar triangles because the instructions told us that. Does anyone have an idea of what a proportion could be that we could set this one up? Okay, Billiam.
5 over 15 and 4 over x.
Okay, 5 over 15 is equal to 4 over... It says D there, so we'll just keep it as D, but the variable, right? Does anyone have a different ratio they would have done? Okay, Kenny.
I don't, but, well, I'll give you one if I can use the rest of them.
Sure.
Okay? And 15 over 5 is equal to 4 over D. D over 4.
Ooh, there you go. Good catch, good catch. That would work. Okay, Seth, do you have one as well?
No, these are here.
Okay, does anyone else have another one that would work?
No, I have another one.
You do?
Yeah.
Okay.
You could do D over 4 is equal to 15 over 5, right?
So you're just flipping the equal sign? Okay, we're going to call that the same one.
Okay.
Okay? Good luck in the restroom, by the way. Buenos suerte en el baño. Okay? Yes, Elizabeth.
What that means.
Could you completely skip that part and just if you had the
Like already do the cross multiplying? Yeah. You want to be careful with it, but yeah, you could technically. Here's another ratio that you could do. Okay, let me say this. If I started out as D over 15, can anyone tell me how the other one would have to finish up? 4 over 5. Set this correct. Let me walk through each of these three and say why they're okay. Let's start with the red one, the one we started with. 5 over 15 vertically, those are corresponding sides. Vertically, 4 over D, corresponding sides. Horizontally, 5 and 4 both deal with the same triangle. Horizontally, 15 and D both deal with the same triangle. Same story on the yellow, we just ended up flipping it, right? But we flipped both. Okay. At first, Kenny said 4 over D, which wouldn't have worked because 15 and 4 have nothing in common. They're not corresponding sides and they're not in the same triangle. But as soon as he flipped the other one, it was okay. The purple one, although being quite different, vertically, D over 15, same triangle. Vertically, 4 over 5, same triangle. Horizontally, D and 4, corresponding sides. Horizontally, 15 and 5, corresponding sides. Are we seeing how that one might work as well? Okay, so is there only one right way to do this? No. Let's look what happens when you cross multiply each of these. We're doing 15 times 4, and we're doing D times 5, right? What do we do over here? 15 times 4 and D times 5. Here we do 15 times 4 and D times 5. So are you doing the same multiplication each time? Yeah, and no matter how many times you do it, as long as you do it correctly, 15 times 4 will always give you 60. And no matter how many times you do it, as long as you do it correctly, D times 5 or 5 times D will give you 5D. Ha. All right. So now we'll divide both sides by 5. And what does the side length E end up being? 12. And this time we have a label, so what is it, 12? Meters. When you have the label, we'll always put it. Okay, questions on that? Miles is MI. ML is milliliters. All right. Questions on that? All right, I want you guys to set up your own proportion on letter C. No blurting. Hey, can somebody tell me what they had for a setup for the ratio? Okay, Gregory.
3 over 5 is equal to A over 15.
Okay, that would work. Did anyone have anything different? Okay, what'd you have, Kenny?
I had it wrong.
Are you sure?
I think so.
Okay, you want to tell me it?
I have 5 over 15 equals, or 3 over A.
That would be fine.
What?
That works.
Oh,
There's 4 ways.
yeah.
I just didn't show one last time. Yeah, Chase.
15 over 5 is A over 3.
That would work. Anyone else have another way? We got 3 of the 4 so far. Did anyone have another one? Oh, we got close, okay? We got 3 of the 4, okay? The other one, it would be 5 over 3 is equal to 15 over A. That would be all 4 possible combinations, okay? No other combinations work than that. So if you had a different combination than that, unfortunately it doesn't work, okay? But all of these match up vertically on both sides and horizontally on both sides. And if we cross multiply any of these, we end up getting the same thing. You have 3 times 15 and 5 times A. 3 times 15, 5 times A. 3 times 15, 5 times A. 3 times 15, 5 times A. So either way, it's 45 equals 5A. Divide both sides by 5. And A is 9. And if we look at this, would it make sense for it to go from 5 to 15 multiplying by 3 and to go from 3 to 9 multiplying by 3? Yeah, totally would. All right, question on that?
Celery.
Okay. All right.
Okay.
Let's skip number D. Letter D.
Okay.
Let's look at letter E, though. Letter E, we have 2 different variables to find, right? Well, here's what we're going to do. We're going to set up 2 different problems. We're going to set up one problem to find X. We're going to set up another problem to find Y. Who wants to help me with one of the problems?
No.
All right, Landon, thanks for volunteering.
I don't know.
I believe in you. Put something out there.
8 over X. 12 over 16. And Y over 21.
So we're going to save that one for the last one. But we're going to do this equation first, okay? So we're going to do this equation. 8 over x is equal to 12 over 16.8. That would work. Vertically, 8 and x correspond. Vertically, 12 and 16.8 correspond. Horizontally, 8 and 12 are the same triangle. Horizontally, x and 16.8, same triangle. This is a proportion that works. One of the 4 that works. Cross multiply. 8 times 16.8. You probably don't know this off the top of your head. That's okay. Christian, William, what do you have that in your calculator as?
8 over 16.8.
8 times 16.8.
134.4.
Okay, and 12 times x is 12x. Kevin, can you tell me what I get when I divide 134.4 by 12? Sorry, say that one more time.
11.2.
11.2, he was already there. So x is 11.2. Now, we need to do a different equation to find y, don't we? Now let me ask this. Now that we know x is 11.2, could we set up a proportion involving that 11.2? We could. Is that maybe the wisest thing?
No.
Okay, why not?
No. Because we already have the work done. Wait. No.
Would you do 11.2 over what?
Because it's 0.2.
You wouldn't do 11.2 over y because they don't correspond and they're not in the same triangle. So you wouldn't want to put them horizontally or vertically from each other.
Because it's not a whole number.
Okay, because it's not a whole number. Okay, and 8 and 12 and 16.8 aren't either though. Okay, is there a possibility that we made a mistake on this 11.2?
Yeah.
It's possible. So would you want to use something that you might have made a mistake on as you continue your work? If you have a choice, probably not. If you have a choice, let's go back to the ones that we know were correct that were given to us. Okay, I think that's wiser. Okay, now assuming we did this correctly, we can use it in a proportion and get the right answer just fine. But let's not assume. Okay, I don't know if you guys have heard of the saying, but you know what they say about assume makes you look stupid. Anyway. Oh, it totally is. Okay, anyway, can anyone tell me what a proportion I might use involving the 8 and 16.8 might be? Or excuse me, the 8 and, not 6.8, but excuse me, but the 12 and the 16.8. Billiam.
Are we talking about y?
Yeah, to find y.
Okay, so 12 over 16.8 equals 21 over y.
I'm going to slightly disagree. Can anyone tell me why I disagree with this? Elizabeth.
Because you're supposed to put the smaller on top when it looks.
Okay.
Should supposedly be the smaller number.
Okay, so because we did 12 on top here and 16.8 on the bottom, we need to continue doing the same triangle on the top, same triangle on the bottom, and y is actually in the same triangle as 12, okay? So we need to do y over 21. That could be one of our 4 possible setups. Any questions on why that would be one of our 4 possible setups? All right, let's go ahead and cross multiply. 12 times 21. Who has that? Chase? 352? 252.8? 252? Just 252, okay. 16.8 times y is 16.8. Y. Divide by 16.8. I'm going to put my answer up here so it's not under the watermark. Y is what, Gregory? What do you get y to be?
Wait, no, sorry. I did my
Gregory, were you asking a question?
Yeah, I'll try to ask you.
Oh, yeah, good luck. All right, y ends up being 15. Y works out a little bit nicer that time. How did it work out nicer?
No, not that. I get that. No.
Okay.
I'll watermark his name.
Oh, I don't know. It was probably how they did it like the older times before, like digitally, where they actually used water to mark it somehow.
That's what I was thinking.
More than likely, my guess. All right. Any question on this? Alrighty. All right. Let's look at F and G, and we're gonna skip H. Okay. That sound fair?
No.
Well, that's too bad. We're doing it anyway. All right. So we're told that AB segment AB is parallel, and we're gonna skip F too. Okay. We're just gonna do G. Okay. G has 2 parts though. We want to know first what the length of segment QT is. Then we want to know what the length of RT would be. if we know another piece of information. Let's first focus on number 1 of G. What is the length of segment QT? So we don't know the length of segment QT right now, do we? What can we call it? X. Okay. Who can help me set up a ratio, a proportion, two ratios being equivalent, that would help us do this, knowing these triangles are similar? Okay. Elizabeth.
3 over 4 and 9 over X.
Awesome. I agree that would work. 3 over 4, okay, vertically, the same triangle. Vertically, 9 over X, same triangle. Horizontally, 3 and 9, corresponding sides. Horizontally, 4 and X, corresponding sides. One of the 4 possible ones we could set up. Does anyone have a different one they wanted to use? Okay. So now we cross multiply. 3 times X is 3X. 4 times 9 is 36. Now what? Divide by 3. And X is 12. Meaning the measure of segment QT, to answer our question, is 12 centimeters. Very good. So that's to remember that label. Questions on how we did number 1. All right. Number 2. If the measure of segment PT is 15, so let's go ahead and mark that. If it's 15, what would the measure of segment RT be? Well, do we know the measure of RT right now? No, what can we call it? Okay, do we want to call it X if we already have an X though? Probably Y. Okay, let's move on to something else. All right. Can anyone help me use a proportion for this one?
No.
Bill, remember want to try this one? Okay. Elizabeth?
Wait. Do we want to use what we found for X?
Okay, great question. We could use what we found for X, but once again, what we talked about earlier, it might not be the wisest decision. Do you want to phone a friend?
No, I think I got it.
Okay.
9 over 15 and then 3 over 1.
All right, let's look and see if this works. Vertically, 9 and 15, those are both dealing with a big triangle. Vertically, 3 and Y, both dealing with a small triangle. Okay, so it works vertically. Horizontally, 9 and 3, corresponding sides. Horizontally, 15Y, corresponding sides. Yep, it works out. It's one of the 4. Kevin, is that the one you're going to use?
I don't know. I'll try mine.
What was yours? What was yours going to be?
15Y.
15 over Y.
Yeah.
Okay.
And then 3 over 4.
So that one wouldn't work, unfortunately. So 15 over Y works because big triangle to small triangle, corresponding sides. But 3 over 4 doesn't work because it's small triangle to small triangle, and 4 doesn't correspond to the other side. So if we did 15 over Y, it'd have to end in 9 over 3, or whatever our X was, 12 over 4. Does that make sense or no? Okay. Love that you tried it though. All right, from here, let's cross multiply. 9 times Y is 9Y. 15 times 3 is 45. What do we get Y to be? 5 centimeters. So the measure of segment RT is 5 centimeters. Yep, that triangle is a 3, 4, 5. Any questions on this one? So once again, don't do numbers 1, 2, and 16. And then 15, you need to know that angles B and H are congruent. Once you have that, you're Gucci.